So let's start off with discount tokens. We talked about discount tokens last lesson, and we said that this is one of these properties that tokens could have. What are discount tokens? Discount token is a right to receive discount on purchases. So it's kind of like a utility function. It does have some form of monetary value, but it's for you to access the ecosystem to get a discount. How is it being used? So firstly, the items, usually when we talk about tokens, the items are priced in the token prices or priced in tokens, but this is not true for this case, where tokens are priced based on their fiat currency or whatever currency that's defined, and the tokens is just to get a discount. So what is it for? It's for services, not for products. Why? Because for products, it's easier to arbitrage. For services, it's slightly different or slightly difficult. And of course, the services that you want to provide must be in general quite similar. Otherwise, arbitrage could exist. Arbitrage is the difference in prices, and then you can earn gains from that. So examples would be licensing of software, product rental. Rental is a service. Catering service. Service is a service, not a product. So is it just fancy coupon? Extreme couponing. So the concept is quite similar, but is it identical? It's not identical. So it's similar as in it allows users to receive a discount. So it's not just coupons, but it could be discount codes. It could be like your frequent flyer miles, where you get discount on your purchase, discount on your stuff. So it's similar because it allows users to get a discount. But the difference is that discount tokens are not destroyed. They're not burnt after it's been used. It's still in your possession. So a similar concept would be stuff like if you are in New York and New York taxis, to be able to drive a New York taxi, we have this thing called a medallion. Medallion is like a coin that represents that you can drive the taxi. So this coin, this medallion, allows you to drive the taxi, and then you can keep driving the taxi, and it will not be removed from you, and it's still in your possession. So that's the concept of it's not being destroyed, it's not being burned. It allows you to tap into the ecosystem, as in it allows you to make purchases on the ecosystem, just like the medallion allows you to be a driver, to be driving on the road in New York and getting customers. So in that way, it's quite similar. And then when you use it to drive your car or your taxi or your cab, it's not taken away from you. So in the same way, tokens are not taken away from you. Discount tokens are not taken away from you. So where does the value of discount token comes? It comes in two different ways. The first one is use value, and second is resale value. So the use value is that when you use the tokens, you receive these discounts, and this discount it's a value. It's valuable because it's valuable as a user. You get discount on the product. That's one value. The other one is a resale value. So if the tokens increase in prices, you can sell it and make the difference. So going back to the medallion story, the prices of this, or value of this taxi, the New York taxi cab medallion, comes in two ways. The first one is use value. So you can use the medallion to be driving around and picking up customers, and you earn profits when you are picking up customers. So that's a use value, and that's where you get value. The medallion can also have a different resale value. So a new person comes into the country and he wants to be a cab driver, and so he wants to buy the medallion off you, and if you get profits in the resale value, that's where your value can come in from. So revenue sold, and the difference in prices is your revenue. So in the same way, discount tokens also work like that. You can sell your tokens and earn revenue from that. So there are 4 general criteria, and these are in English words. If you refer back to the lecture notes, these will be done these will be shown in mathematical formula. So these are the different criteria, or we call them the constraints, when we are building the ecosystem. So what you want to do is when you start, you want to think a little bit more about, okay, discount tokens, that means, what does it mean? It means, okay, this, that, and that, and then you list them down, and then you find out how to put them into math. Then you can model them. So what are the 4 general criteria? The first one is if it's, these are all very straightforward stuff. If no tokens are activated, you don't get any discounts. Pretty straightforward. When the amount of tokens is used is the amount where the service is free, the discount received is 100%. So this sounds very basic, but we can put them into a formula, and this is an important formula because now we know that the total amount of tokens used equals the service equals when the service is free. That means discount is 100% or it's 1. And this is a new constraint that can be very helpful in designing your function. Third is when the fee of the service increase, more tokens will be needed to get a discount. Make sense? When you buy more items or when it becomes more expensive, the service is more expensive, then you need more tokens to get the same amount of discount. And the maximum token used is when discount is 100%. That means when the service is free. So you have a constraint where the maximum tokens will be less than or equals to, or the maximum tokens will be equals to when discount is 100%. So this is the general framework, general criteria that you want to put in place. So your model will be subjected to all these constraints. Of course, they don't necessarily have to be, you don't have to apply them to your ecosystem, but this is just a base model to get started. For example, the maximum tokens used can be less than 100% because whatever kind of reiterations that you want to make in your model, but it doesn't matter because this is the general framework. You don't want to add so many assumptions, so many variables. You want it to be a simple model, and in a simple model, this is what it is. And there are 8 functions of a discount token. I go all in details in the lecture notes, from cost of service, discount model, network utilization matrix, operating revenue, effects of network growth, how do we model that into the valuation of tokens or the valuation of the discount, the value from utility, how does increase in utility increase the value, looking at operating costs, how do we factor operating costs into these the operating revenue, and the usability of token versus investing in tokens. So how do we want to, because we are getting value from utility, so we want tokens to be used, and we want to incentivize that behavior instead of incentivizing the behavior of investing. So everything is gone into details in the lecture notes. I really want to talk about those highlighted in the box. So we're going to talk specifically at the cost of service, the discount model. So these are the foundational, all of them have math in it anyway, and these are the foundational formulas for you. Value from utility, as well as the usability of tokens versus investing. So let's get started with the cost of token. So the cost of token, this is what the formula is. You've got C, Y, and X. So the cost of token is dependent on the cost of service is C, is dependent on 2 variables, Y and T. Y is the tokens activated, so how many tokens will be used. T is how many tokens will be used, and Y is the quantity purchased. So it could be 1 if you're talking about licensing a software, or it could be like renting a space, and that could be a different, you can calculate Y in a different way. Okay, X is the state of the network. So how active it is, how many tokens are being used, how many tokens are active in the space. That's the state. So the cost of, that's the cost of service. And how do we look at that? We look at cost times the quantity purchased, as usual. Cost times quantity purchased times 1 minus F, this function F, this is discount received. Okay, F is the discount function, and 1 minus the discount function is the amount you paid. So for example, if the cost is $10, you're buying 1 item, and the discount is 10%. So that means $10 for C, Y is 1, so that's 10, and 1 minus 10% because you get 10% discount. So that means you only pay 90%. So 90% of 90 is 9. Of 10, 90% of 10 is 9. So this is basically, the cost of the service, the cost function. The cost function is dependent on tokens activated, the quantity purchased, as well as the global network state. So the discount model. The discount model show what we're looking at is that the services can be purchased with or without tokens, and prices are set by the service provider, just like how like bread is set in the supermarket and or tuition fee is set by the tutors. So you can just buy the service anyway. You can have no tokens, you pay in fiat and you get the amount, or you pay with some tokens, or you use some tokens, not pay, but use some tokens to get a discount. And the amount received is directed by the needs and utility of the tokens. That means of the network. That means as the utility of the network grows, the discount size also grows. And you can put that into a mathematical formula. Now, we want to consolidate. Now, this is a bit more interesting where we want to look at value from utility. So how do we derive value from the utility of the system? So we are looking at a formula. We're looking at the utility value per token activated per unit time. We want to add per unit time in because when we're looking at services, we can have two. One is time-based services and one is quantity-based. So time-based will be stuff like I have to rent a dress for a night, for 5 hours for a wedding. Time-based can be I'm looking at a license. I'm licensing a software for 12 months. Time-based can be I am going to a class by a chef who's going to teach us how to cook a very interesting meal, and there'll be a one-day event, so that's time-based. Then you have non-time-based. So non-time-based can be probably rental of an asset, so the amount of assets that you want to rent. So that could be rental of space. So I want to rent your computer space to be hosting my items, and I want to host it for I don't know how long, doesn't matter, but I want to rent 1 gigabyte of your computer space. So that will be quantity based. And how do we want to look at the utilization value? So let's start with a simple one where it's time based. So what is the function? The utility function will be cost over a parameter. So beta is a parameter that you just C is cost. Beta is the parameter that you have that you just input into your ecosystem. So if you read the lecture note, we talked about beta because we're just adding a new dimension to add variables, and we can complicate things a bit better. We can create more sophisticated model, and that could be something like we want to look at getting operating revenue. So we're going to add a beta, which is more than 1, into your ecosystem. And then you have XT, which is your tokens activated, and XU is the total tokens that's being utilized in the ecosystem. So you have this function. And when we look at time-based service, the value can come in two ways. The value can come from buying and using the token, the discount token, or holding on to the tokens, and it provides a return. So if we are looking at holding on to the tokens, so this is one value, right? The valuation here is where you buy and use the discount tokens, and holding on to the tokens that provides a return R. So this could be something like the value of the tokens will increase because the license of the software will the license of the software become more popular because everyone will have to use this software and more people want to demand a token. So you can look at an expected return R. And then we use the net present value, which is a geometric series. We talked about that last lesson, the different kind of math available. And this will be in this function where you have a 1 over return on the utility here. So basically you have the return, which is an interest rate or R, into the function. So that's how you can calculate the value of utility. For non-time based, right now you don't see Y, right? Here we talked about there's Y here. cost has a Y in there. But now we don't see Y, we just look at C. That's because we assume Y is 1, because we only need 1 license per period. But if we are looking at a non-time base, then we have to add Y in there, C times Y together. And then the Y will be the unit of service per activation. So 1 gigabyte every day. And I want to rent it for. I want to rent more than just 1 gigabyte. I want to rent 5 gigabytes tomorrow. So what will be the value? And lastly, we want to look at the incentive to use tokens. Why do I want to talk about that? Because there are 2 types of uses for tokens. You either use it and you get value, or you, like the New York cab drivers, right? The medallion, you can buy it and use it, you get value, or you can hold it and wait for it to rise in value and then you sell it. So now we want to incentivize people to use it. No one will buy a New York cab medallion just to keep it at home and just display to everyone and show, hi everyone, see I've got this medallion. There is no value in that because it's an opportunity lost. It's an opportunity cost to just leaving it there. You have to use it. So by using the tokens, the user will always get perpetual discounts. So that's a value there. The value comes from using it, and then you get discounts of value. Then you get value again when the token prices increase, and then you sell it off to make profits. That's the second value. So for a user, you have values in 2 ways. You get economic benefits, which is the difference in prices, you sell it off, and economic savings, which is you get discounts. Whereas for a token holder, just an investor, you're just holding the New York taxi medallion just to wait for it to increase in prices. You're not even going to use it, you're just going to keep it at home and show off to your friends who come to your party. So if that's the case, they only make economic benefits from selling it at a higher price. What are they losing out? They're losing out this part. They're losing out that using the tokens to get perpetual benefits or perpetual discounts. So the whole goal here is to incentivize users to continue receiving, to continue to use the tokens so that they will receive more economic benefits and economic savings instead of just being an investor and holding it. Because why do we want to do that? Because in the previous slide here, the value from utility, the value of tokens comes from the utility of the tokens. So how many tokens is being utilized and then you get the value from that. So you want more people to use the tokens. That's why we are having all these concepts and just formalizing them in math models. So that's the general gist of discount tokens.